I will talk about UDF alternative using the new feature in ANSYS FLUENT 2019 R1. Some people confuse the 2019 R1 with 19.1. 19.1 is the old version. This is the latest one. It may be called, when you set up it, you will see that the name is 19.3. So this is the latest version. Or the official name is 2019 R1. Okay? We all know that the limitation of the old versions of ANSYS that any input we enter in the interface must be constant. We have no other option, only constants are allowed. There is another option called the new input parameter, but this is also allowed only constant. It only gives me an addition that I can modify the variable from the workbench. Or if you activated the new input parameter, instead of constant, you give the parameter a name, but again you can't enter a formula or expression, only a constant. But you can change this constant from outside, from the workbench. You will find that there is something called the parameter set, and you use this to change the value of this parameter, but only again with constant. You can't enter a formula or expression. Okay. There are some places you can change this to a formula, like the properties window of air. As an example, you can enter a formula in the form of a polynomial function, only a polynomial function. You don't have many other options, and it will be a function only of temperature. You can't change it to function of pressure or density or anything else, just temperature. Okay, so all of these are limitations in the old version. In the new versions, we will find that there are small arrow beside the box from which you will enter the value, and you can choose expression in which you can enter an expression. I think I show you this before in the previous seminar. Okay, and you'll find this new box, arrow box to enter the expression, and by clicking on f of x beside this box, you can see many other options to enter some different kind of function, mathematical function, conditional function, trigonometric function, and the different variables are available, and the different constant to use it. Instead of using just approximation, you can use more accurate value for these constants. Okay, first thing to know about the expression is how to write them. The syntax of the expression. There are different type of data can be written in the expression. First thing is Boolean. Boolean is a variable which has a true or false. It's used with conditional statement like if statement. This is called the Boolean. And there are single value parameter. I'll talk you about it later. And there is field parameters, and there are numbers. Only number without a symbol. When inserting a number, you must take care that you use the units. If a number has a unit, you must define it. You can't leave it without a unit in a dimensionless form. Okay? Like if you are the input is 5 meters per second, it's a velocity, you must specify that the number is 5 meters per second. Okay? Now what is a single value parameter? Single value parameter is a parameter which returns a single value, like time. If the formula is dependent on time, at each iteration and at each time step, time t, the variable t, will return a single value, which is the time at this time step. This is called a single value parameter. Iteration, you can use the iteration count in the expression also. This is a single value parameter. All constants are considered single value parameters. There are different kind of parameter, which is called field parameter. This is a parameter which return a value for each cell, like the temperature. The temperature, if you use t in the equation, which t? We have t for each cell in the domain, has its temperature, x coordinate. Most of the variables are considered field parameters. What happens when we use field parameter in the expression? Like this domain, this is an example, it's a pipe. I want to define the temperature across the surface of the pipe, I use this equation. This means, using the equation this way, we have x, which is a field parameter. Each cell has its x coordinate. So what happens when ANSYS finds this kind of formula? It recalculates the expression at each cell using the corresponding x value to calculate the temperature of this cell. Okay, so the temperature is calculated several times at each cell. Is this clear? So this is how field parameters are calculated. And we can do something called the reduction of the field parameter, which is converted to single value parameter. Like if we want the average temperature of a fixed surface, we can calculate the average temperature. So T, the temperature, is a field parameter, but we are taking only the average of all cells to use it in the expression. This is called the reduction function. We will talk about it in more detail later. The main operators that will be used in writing expressions are the most common operators: addition, subtraction, division, multiplication, and the power. Power is a different one. It's used in this form using double asterisks, not in the hat symbol. It is not used. Okay. And for conditional statement, also we use the traditional operators: greater than, less than, greater than or equal. Or I think all of you know these operators which used in conditional statement, like if using if else. Okay. This is an example to calculate the temperature, to define the temperature along the z direction of the pipe. This is a pipe which is extruded in the z direction. So I want to define the temperature as a variable of z. Okay, this is the main equation. Will be written this way. As you can see here, the power z squared is written z double asterisk 2. This is how z squared are written. And when I use this number, I must define a unit for it. This formula must give me the temperature in Kelvin. So each term of this equation must be, its unit must be in Kelvin. So I have to define the temperature as a unit for this number to be Kelvin per meter squared, to be multiplied by z squared to give me a Kelvin. Okay, so this is a formula written according to the operators I defined earlier. Okay, is this clear? In the units definition, you can use the symbol, the hat symbol in defining power, only in the units definition. But inside the expression itself, you must use double asterisk. Okay. This is how we will find the temperature after defining this equation. If you draw the contours of temperature across the pipe, you find it a gradient of temperature, not a constant value. Okay. Another example, if you want to define a velocity at the inlet, which has a laminar velocity profile, which changes in the radial direction R. We know that this is the equation of the velocity for laminar flow, V equal V maximum multiplied by 1 minus R over R capital all squared. In ANSYS, we are dealing with Cartesian coordinates, so we must define R as a function of x squared, square root x squared plus y squared. If we substituted this in the main equation, you get this form. Okay, we want to write the expression for this equation in the velocity inlet boundary condition. Okay, this is how I wrote it. 0.1 meter per second, this is V maximum. I have to define the unit. This is important. If you didn't define the unit, it will give you an error. Then I opened the parentheses and written the rest of the equation as you can see here. I want you to notice that I've written R capital in the unit of millimeter. There is no problem here that you use another unit as long as it is length. This is a unit of length, so no problem. ANSYS will convert the unit for you. You can use millimeter, meter, centimeter, no problem. But you have to define a proper length dimension. Okay? Is there a problem in writing this equation? There is a more robust form to write this equation instead of using this one. Say that V maximum, which is 0.1 meter per second, are used in several expressions. So, and you want to change it. So you will enter each expression and it changes 0.1 to another number, which may cause error. You may miss some value in the equation. So it's better to define V maximum alone, then use V maximum in the expression. So when you want to change V maximum, only change its value once and it will be updated according to this. So there is, in the tree, on the left side of FLUENT, you will find something called the named expression. By right click on named expression, you will find the new option called new. Okay. Here you define a new variable, any variable you want, with the specific, you may use formula or expression, or you may use constant value. So here I defined V maximum, I set the name here, and define the value 0.1 and also the unit. It's important to define the unit. So I defined here V maximum. And I will define the value of R small, instead of using directly the square root of x squared plus y squared in the main expression. I will define R alone to be the square root of x squared plus y squared. Now I use these two Again, I define R maximum also to be 25 millimeter. Now I will use them to be in the main equation of the velocity profile. V maximum multiplied 1 minus R over R maximum all to the power 2. This is clear? This is easier to write and to edit and more accurate. This is how we find the velocity profile at the inlet according to the laminar flow. There are a lot of functions provided in the window, the main window of the expression editor. Conditional function, mathematical function. I will provide you with a PDF file showing all these functions and how to use it. The file will be something like this. This is a conditional function and if not or, and some mathematical function, absolute, seal, exponential, floor. These are all mathematical functions. This is the description of the function and how to write it. Of course, I don't have time to explain each function. So I will take two examples, f function and the average function, and will show you how to read the description. This is the description. If you understood what is written here, you can write any function. And as long as you know what the function do. And this is the easy part because the name of the function is very descriptive. You know what if do. If checks to something, if it's true, it applies the equation. If it's false, applies another one. We all know how if works. But yes, yes, similar sentences. What you need to know is how to write this equation so Fluent does not give you an error. Okay, so first rule, this is a description of f. You write everything as it is. If there is something written in capital form, write it in capital form. If it's written in small letter, write it in small letter. If there is a specific type of parenthesis, use it. If there is a comma, use it. The same, you write it down again. Okay, except these symbols, the larger than and the smaller than. When you find these symbols in the description, you remove them and write what is described between them. Okay, so in this case, you have at the first term here, we have between these symbols condition, which means condition. So I have to write here the condition which will be checked. The second part, true value. This is the value which will be executed or used if the condition is true. The last term, as you can see here, false value. This is a condition or the expression which will be used if the condition is false. Okay, so this is how the f function will be used in the expression editor. As the same commas here I copied them without changing them. The same parenthesis type are used and using f all in capital letters or copy. All copy. Okay, I will try this example of defining a source term which is time dependent. It changes with time. This is assume this is the radiation in watt per meter cube. Radiation absorbed in watt per meter cube. Okay, and it's a variation with time. And this is the equation describes this variation. Okay, after this time at 32,400, the equation can't be used. There is no radiation, so we must use 0. The source term should be 0. This is the case which I use the energy source term to define the energy absorbed by solar radiation in the fluid. Okay, is this clear? The description of the case, or what?
So you said you said it becomes 0.
What?
You said the solar radiation becomes 0, right?
Yes, solar radiation equals 0 after this time.
After this time.
Yes, so I need if condition to if the time before 32,000, he will use this expression. But after 32,000, the expression must be 0.
0.
Yes, I need to define this in the expression window. This is I opened the source term. I found, as I showed you earlier, the expression option instead of constant, and this is the expression editor. I wrote f, first thing f, I opened the parentheses, then this is the first thing, this is the condition, t less than or equal 32,400, and I have to define units. This is a comparison between time and another number, so the number must be in seconds, so you must define the unit. So I put here second in the square brackets, then comma. After that, this is the equation which will be used if the condition is true. I wrote down the equation I showed you earlier, this equation. I wrote it down here until reaching there. As you can see here, this is supposed to be source term, so its unit is watt per meter cube. So this number has to have the dimension of watt per meter cube per second to the power 4, because it will be multiplied by time to the power 4. So when multiplied, it will give me the unit of watt per meter cube. So each number of those these numbers must have a unit. This will be watt per meter cube per second to the power 4. This one will have watt per meter cube per second cube. This one watt per meter cube per second square, and so on. Okay? This is how I wrote the equation, which will be executed if the condition is true. After that, I put a comma. Then the last equation is the equation which will be executed if the time greater than 32,400, which is 0. Okay. Now this is define a source term which is time dependent and different for different time periods. Okay. Another example, the average function. If you want to calculate the average temperature at a specific surface or specific volume and use this average temperature to calculate some other property dependent on it. Like in the same case which I just explained, if you want the absorptivity of the, hypothetically speaking, the absorptivity of the water, it changes with temperature, assuming that. So you need to know the temperature, average temperature, so that you calculate the average temperature, then calculate the absorptivity, then multiply it by the radiation to calculate how much energy is absorbed. So you need to define the average. How to define the average? This is the function, the average function, and how its description is written. So I will apply the same rules I just mentioned. I copied everything as it is, average, open the parentheses. Then the first thing here is expression. You write here the expression which will be averaged, what you want to be averaged. In the case which you want to, in which you want to calculate the average temperature, you will write here T, which represents the temperature. Okay. Second thing, here you find the location. Of course, I will write first the square bracket. Then I find these symbols, it's greater than and smaller than. I remove this at all. And right here in this location, the location at which I define the average temperature. Okay, but I have to, I use the name of the boundary, inlet, exit, whatever name I used in ANSYS mission, I defined it in name selection. I will use it here. Okay, but I have it to put it between these quotation marks. Okay. Then after I may use any combination of location. I may use a different location, more than one. No problem with that, as long as I'm using commas between them. Okay. After finishing the location, there is something called weight, which has three options: none, area, volume. These are three options for calculating the average. None is the arithmetic average, which is adding all values and dividing them by their number. This is wrong in our physical cases. We must take into consideration the actual surface area of each cell, because it affects the average temperature. If there is a cell which is very large, the average temperature will be nearer to it than if the cell is small. Okay, so if you are taking average for an area, you will write here the weight to be area. You write here the word area. If you are taking the average over a volume, you write here volume. So this function will calculate the average temperature across a volume or a surface, whatever you need. And this is what I just said, that you can use many locations as you want, no problem with that. Let's apply this for an example, saying that the absorption of water for radiation, it changes with time, with temperature, according to this equation. So I want to define the average temperature of the fluid, which is the volume, not area, and define an expression for calculating alpha, which is absorptivity of water. Then use this alpha to change the source term, which I just defined to be only function of radiation without considering the observativity. Okay? So now first thing, I will define named expression, new named expression, define the average temperature. Here is the function I just explained. Average, use average, open the parentheses, then the variable which will be defined or calculating the average of it is t capital. This is the average. If any other variable you want, you will find them in the list here. You have a list of variables here. So any other variable, pressure, anything you will find in the list of variables. Comma, after the comma I define the location. The location is the volume of the fluid. I define its name in ANSYS meshing to be fluid. The zone, which is the name of the zone, is fluid. That's what I wanted to calculate the average for. If you want to calculate the average for just a surface, find the name of the surface and write it there, no problem. Any surface or volume. Then I close the square bracket. After that a comma, then weight equal volume, because this is the average across a volume. This will calculate the average temperature across the volume of the fluid. After that I calculate alpha, which is observativity. This is the equation I just showed earlier. Negative 0.002 multiplied by T average is plus 0.956. Of course, the unit of this number, alpha is dimensionless, and this number will be multiplied by Kelvin, so the dimension of the number must be Kelvin to the power -1. So that the whole equation will be dimensionless. Now this is, I return it back to the equation of the source term, the same equation, but I multiplied it by alpha. That's it. Okay? Yes. This is expressions. This is how to use them. I can show you here the file, which is
much easier than before.
yes, you don't need to use UDF at all.
So that's what I want. What I'm wondering. For me, this thing is going to use, going to calculate these averages and this thing every time step or every iteration.
No, every iteration.
Yeah,
Every iteration.
For every time step you go to update the values.
The boundary conditions are calculated every iteration.
No, I mean the bound. I mean the equations is depending on the time.
Yes, it's dependent on the time.
Yeah,
yes,
so
but
every time to be calculated, this is consuming computational power for your experience.
maybe I don't think it will consume more power, but I don't know if FLUENT check if this is dependent on time only or time or another variable.
That's what I'm saying.
I don't know if it checks that and determine what it will do. I don't know. You may try it.
Yeah, I just want to just tell you I want to update it maybe every 10 time steps of 20 time steps. I can search.
I don't know if this is possible or not.
If you can share just the manual, the tutorial of UDF.
UDF? Maybe I have the manual.
Yeah, okay.
This is a list of all expressions. These are operators I just mentioned. This is all conditional statement. If you want to the if condition here, you put here a condition. Okay, so sometimes you want multiple conditions, something and something. So you use this. You use the AND function, and put here all the expression you want to check. Okay, we have here all the mathematical function, hyperbolic functions, sine, tanh, cosine.
It's like the east program.
Yes, simple. It's similar. These all again mathematical function, logarithmic. If you have multiple numbers and you want to calculate the maximum, simple function. Square root, here's square root. This is a reduction function. If you want to calculate the area of a surface, you use area. Then put the name of the surfaces between the parentheses. This will calculate the area of the surface. If you want the average, I just explained. Maximum. If you want the maximum temperature across a surface or across a volume, you write maximum. Then what is the maximum you want? Temperature. You write here temperature as an example. You write the location here. This will calculate the maximum. Minimum, same concept. Some, if you want to add a specific value across the whole surface, maybe mass flow rate, calculating mass flow rate. maybe.
Can I
What?
put the coordinates in the location instead of the name?
No.
You can make a new surface. I think.
I don't. No. You can't.
I think
Location. You must define a location in the form of a name.
But I think you can make a new surface with the coordinates you have, and then
Give it a name. If
Yeah, give it a name,
you have
yeah.
a name, give it a name.
yeah.
This is trigonometric function. That's it. Do you want any to ask anything?
Yeah, very simple.
If you want something to have a concept in your mind and you want to apply, maybe you tell me. We'll think about it.
So now is a simple problem I have in my simulation. If I have something variable that cannot be described with an equation, have it in Excel file or something like that.
Maybe use the f function, but a big one.
If function, yeah, very big one.
Yes. Maybe I don't know other method.
Yeah. So I will enter this all
But how you don't have any equation? Maybe
something like the wind speed over the day. It's just fluctuating. The ambient temperature is not going like that. Maybe the ambient temperature.
Maybe divide it in smaller portions. Or
Yeah, maybe I will write small equations for using f for every time I have a question. I have a good idea.
maybe this will help you. I think.
But till now there is no way of importing data from Excel file.
No, I don't think so.
Because I searched it online also, I cannot find it.
I found it in another program. It's in ANSYS Mechanical. There is something. You define a table at the
Yeah,
end
that's
of
what.
the table.
Yeah.
But in Fluent, no option for this.
Maybe it's introduced in ANSYS 20.
Maybe.
Yes, it's the demise of the UDF.
It's what I didn't
The
really.
demise of the UDF.
Yes.
UDF because
UDF is still very powerful. UDF has many other options.
Yeah,
you have the computational power of C++. You can do many things.
Yeah, but mostly that's the most common thing.
Yes, this is most common. You don't need it. But in my case, I have maybe 10 surfaces. Each surface has its own equation. Okay, so in C++, I can define a way so that the UDF determines the equation for each surface automatically. So I don't have to enter for the expression editor for each surface and define for its equation. So I have to change the equation 10 times for 10 surfaces. I don't have to do this in UDF. I defined I've written a code which defines this automatically. It can determine this is the surface, so it needs this equation. Just to change some numbers and continue. So this is not. I don't think you can achieve this in this simple way.
It's just limiting the headache. If someone just need to put a small equation, you don't have to go through all this.
Yes, it will be very hard to define just a velocity profile to go in programming and defining.
Yes, it happened to be in my master's studies in my university. It told me I will give you A+ if you have made a UDF code for me to define the variable velocity. So for me, I just downloaded this is a big very well.
It's a 800-page book.
Yeah. Cannot find
for something very simple as a concept.
Yeah.
It's just a velocity profile. I take care about something I forgot to say that all dimensions or coordinates are relative to the origin defined in the design model. So if you want something to be related to a specific place, you must use there is some equation used for transforming coordinates. We took in the math classes years ago. I don't know if you remember it or not.
Yeah.
You must take this in consideration. If you want to check anything, I'm with you. If you don't have any questions, then.
So I want to ask you something in this version. Yes. If you want to ask the data, save the data in text file, it was much easier in 17.2.
It's hard here?
No, I cannot find it in the same place.
What?
I cannot find it in the same place that I'm used.
Save in file?
I want to show, if you want to go for monitors.
Yes.
If I want to save, let's say, temperature with time or iterations. In text file. I can find this.
With time?
Yeah, with time.
I didn't try anything unsteady.
If it was iteration.
For me,
It is calculated easily. When you report to definition, you just have an option to print to save to file.
yes,
I think I try it here. Let's hit finish.
In my case, I saved the torque with time.
Okay, let's try new report to
سايب لما
definition.
في ايه؟
Area weighted average maybe. This option report file.
Yeah, good. The different places of 17.9.
Maybe I didn't use 17.
Yeah,
I only used 18 and 19.
you have to make it right and report different interface.